When you visit Arizona, time is measured in moments, not minutes. Like the moment you see the Grand Canyon for the first time. Visit a new state of mind. Learn more at hereyouareaz.com.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again, and thank you for joining us on this, the Space Nuts podcast, episode 255. My name is Andrew Dunkley, your host, and the man with the brain power to make sense of it all is the one and only Fred Watson, Astronomer-at-Large. Hello, Fred.
Hello, Andrew. Thank you for that. Some would doubt that, but that's all right. Nearest and dearest of many varieties.
Oh, well, you just take it on the chin. That's the way I've spent 34 years of marriage.
Yeah.
Take it on the chin. Speaking of taking it on the chin, Fred, I know last week we were talking about my impending COVID-19 vaccination.
Yes, we did. Yes.
And you said you had absolutely no symptoms whatsoever other than maybe a bit of a sore arm. Well, I went and had mine on Monday, the AstraZeneca vaccine.
Good stuff.
It wasn't a difficult process. I went in, they identified me. They used a mugshot for that, by the way. They asked me a few questions, and because of my history with vaccines, because I have reacted to them in the past, I got to spend extra time in the special room afterwards.
Oh, God.
But yeah, they did the deed, and I spent the rest of the day quite happily. But I was not after effect free, unlike your good self. I had cold shivers that night. I had hot and cold flushes. I had body aches and pains. I had a headache. And the next day was just, as in yesterday, just full-on lethargy, just headache and lethargy all day. And then I felt a bit better towards the evening, and I was speaking to a friend of mine in Queensland who has also had his first injection. He said, "When did you have it?" I said, 10 o'clock on Monday morning. He said, "Okay," he said, "you're going to have one more weird night." And I said, "What's that mean?" He said, "You'll find out." And I thought, okay. And he was right. About 3:30 this morning, I woke up in a lather of sweat. I was so drenched, it was like I'd been standing under a shower. My hair was soaked. Everything was soaked. It was strange. But then I woke up, I got up and dealt with that. But when I woke up and got on with the day, I didn't feel too bad. I feel pretty good at the moment, just maybe a little bit of fogginess. But other than that, I'm through the worst of it. So,
Very good.
Some people have side effects. I sound like I had them all, which is just
That's
what
good,
I wanted.
'cause I didn't have any, which is great.
Yeah, my father didn't have any either, but my mother had the same as I did. So obviously I got her DNA.
Yep.
Thanks, Mum.
Yep.
But yeah, look, I know a lot of people are scared to get it done for those sorts of reasons, but not getting it done opens you up to something much more scary.
Oh,
so
indeed,
I think
yes.
a day of discomfort is certainly a small price to pay. Okay, today we will be hearing questions from our audience. We're 100% dedicated to questions. The answer to all of them is yes, and thanks for joining us. We'll see you next week. I love that joke.
I know you do. I've heard it before.
About 50 times.
Yeah.
We're going to hear from Ashley, who's got a triple banger for us. Christian wants to know about the rotation speed of the Earth. We're going to hear from Marius about exoplanet J1407b. John wants to know about CMB, and we've got Jerry in San Diego who's got a question for us, and I think there's one more that I've missed. Mark from Newbury. About hydrogen in the sun and looking at the length of that question. This could be a very long show. But anyway, we'll get through all of those.
We will.
We'll get through all of those today. So let's start, Fred, with our first, which is an audio question from young Ashley.
Hi, my name is Ashley, and have you guys tried the Oculus space like it's like a virtual reality thing, like you're on the ISS. So I did that today, and what I also have another question about is what happens if we had no atmosphere, and also what do you think there is any other animals out there, and do you think that we'll find them first, or they'll find us first?
That is a good question. We'll get to that in a minute. Oculus. I did do something recently, Fred, which involved the International Space Station. I don't know if it was Oculus, but it was on the ISS website where you can use a simulator to dock with the International Space Station. And I had a crack at that, and it is really quite a lot of fun, but it requires incredible concentration, because the closer you get to docking your spaceship, the harder it is because of the variations in thrust and yaw and pitch and all the angles you've got to take into account. And because I was trying to steer with a keyboard, and I'm sure they don't have to do that on a spaceship, it got more difficult, because as you get closer, you've got to make more subtle changes in direction. And I found it very hard. And in the middle of it all, I got called away. So I had to stop the spaceship, go out the back and load bricks or something, then come back in and start again. And when I came back, the spaceship had drifted hundreds of meters away, and I had to redo the whole thing. But I did succeed on my first attempt at docking.
Very, very good.
And it is the same as the simulator they use at NASA, apparently, or wherever it is. Yeah. So I don't know if that's Oculus, but I had a go at that. And, yeah, it keeps your brain ticking over. You've really got to concentrate. I enjoyed it. It was fun.
Okay.
I'm not sure if that was Oculus, though.
No, it's not.
Okay.
Oculus is a system of virtual reality headsets, most notably the Oculus Rift, which were introduced back in 2016. I was thinking, I've heard of them for a long time and never had a chance to have a shot at one, at using one. So it's a virtual reality system. I mean, virtual reality's come into popularity, and of course you can do it now if you've got a headset that will let you use your mobile phone to produce the two images that give you the stereoscopic vision. But Oculus was one of the early ones, and it would be sensational to be on the ISS with an Oculus Rift headset and the system providing the backup. I'm sure you'd get every sensation other than gravity of being on board the spacecraft. And it may well be that what you did, that system that you did to dock with the ISS, might be available as an Oculus Rift program, or Oculus.
Could be.
As Ashley mentioned. I've not done it at all, but it's great stuff.
Now, Fred, the second part of Ashley's question was about what would happen if there was no atmosphere. I assume no atmosphere on Earth is where we're going with this.
Indeed, yeah. The answer is, Ashley, we'd be in deep trouble.
Deep, very deep.
Very deep, yeah. The oceans would boil, and the water vapor would all be lost to the space around the Earth. That would leave the Earth looking very interesting, because there'd be all these deep valleys and rifts and things like that with no water on them. But there wouldn't be anybody there to see it either, because we would boil too. Our blood would boil, which would not be healthy. So fortunately, the atmosphere is extremely stable. It does have variations in it, which we hear about in the news every day. It's called the weather, plus climate changes, which take place over longer periods of time. But without the atmosphere, we could not possibly exist. And that's why there's no life, we believe, of any kind on the moon. The moon is a world with no atmosphere. It's got a very, very thin gas around it, which we call the exosphere, but it's nothing like an atmosphere like we have here on Earth. So we don't want that. And I think the last question, Ashley, was about animals.
Yes. Are they out
animals there? Are they out there? We don't know. There may be. It's really interesting, because I think the opinion of astronomers and the scientists called astrobiologists who look at life, the possibilities of life out in the universe, they seem to be less convinced that we'll find animals in space. We might find microbes, but animals might be just a step too far because they might need all kinds of accidents on a planet in order for them to form. Well, your final question, will they find us before we find them? Well, that's possible as well. We might be sitting here saying, no, there's no animals out there, and suddenly one appears. But for an astronomer, that will be a very interesting experience. Something
Absolutely.
I'd really like to do.
Now, Fred, speaking of animals on other planets, I believe some years ago there was a fabulous April Fool's Day joke that was played. I think it was in newspapers or some sort of scientific paper that was released that suggested that Mars was populated by exotic animals of all kinds. They kind of described it like the Great Plains of Africa, if I recall correctly, and it sucked everybody in big time, just hook, line and sinker. And I suppose, I don't know when it was, but it was just one of the great April Fool's Day jokes, or it may have just been something that somebody did outside of the April Fool's Day regime. But yeah, I do recall it. It's worth looking up if you want to follow it up, because it is rather amusing.
Will do.
Yeah. Now let's move on to our next question. This comes from Christian in Brazil. This is a text question. Hi, Andrew and Fred. Thanks for your wonderful show. In relation to your story last week about the Earth spinning faster, probably wasn't last week if I recall, can Fred shed any light on the Earth actually spinning slower in the distant past? I had heard that when the dinosaurs were around, one day on Earth was about 18 hours long. Could this affect the gravity on Earth, making things grow bigger and heavier? It's hard to believe those 70-ton dinosaurs could have walked around with such tiny legs. Thank you. Thanks, Christian. Good question. And I do recall this coming up before, I think.
Yeah, yes, certainly we've talked about the Earth's rotation. And I think the thing Christian is referring to there, we spoke about, there was a report that I think last year, the day got very, very slightly short period, rather than the usual lengthening of the day, which comes
That's right.
Spinning. I think that was what it was. Generally speaking, when we look backwards in time, we find the Earth spinning more quickly. And the thinking is that when the Earth, and I'm going back 4.5 billion years now, the day was maybe as short as 4 hours.
Whoa.
Never shorter than that, though, because one of the early theories for the origin of the moon was that the Earth was spinning so fast that debris spun off the equator. It would need to have been spinning quite considerably faster than once every 4 hours for that to happen. So the early Earth was a rapid spinner, and it slowed. Now, Christian says he's heard that when the dinosaurs were around, one day was only 18 hours long. It's certainly shorter than it is now. I'm not sure whether it's that short, though, because that's only 66 million years ago, which is not in this sort of cosmic timescale that we're talking about. So I suspect the day was shorter than 24 hours, but maybe not quite down to 18 hours. But his questions are good ones. Could this affect the gravity on Earth, making things grow bigger and heavier? To some extent, that's true, because a faster spinning Earth gives you more of a centrifugal force on the equator, a little bit lighter. And in fact, we can see that change in gravity now, even with our equipment is so sensitive that you can measure the difference between a person's weight on the equator and on the pole, and they're slightly different. But it is a very small effect, and I don't think it would have any significant influence on the way things evolved, at least not when you go back, 100 million years or so to the era of the dinosaurs. I think the reason why they grew so big was just, it was just an evolutionary, almost an evolutionary dead end to make them bigger and better, and they ate more things and all the rest of it. Their legs were pretty colossal, though. When you look at dinosaur skeletons, they weren't tiny. They were pretty substantial structures. So yeah, great question though, and we should talk a bit more about the way the Earth's slowdown has gone over the geological periods. It's because it would have certainly influenced the way things worked.
We can probably dedicate a segment to that in a future episode, possibly.
We can. That sounds good.
Yeah, I guess a great many people are fascinated by the era of the dinosaurs and what the Earth was like. But when you look at history, Earth has been changing constantly and has had many and some significant variations on different parts of the planet at different times. It's quite extraordinary when you look back and find out what happened. I read an article only yesterday. They were doing mud sampling from the bottoms of rivers and lakes and discovered that climate change probably started 4,000 years ago, not 300 years ago, as we've all been told. That the human impact on Earth's atmosphere and Earth's climate probably began a lot longer back than we've considered.
Yeah.
Oh, yeah, and like the clearing of forests, and they can tell through the pollen samples over, layer upon layer. And they did the experiment by going back 18,000 years at a time where the Earth was coming out of an ice age, and were able to use that as a baseline to compare each series, each period of time that they were looking at. And the pollen samples clearly show that the human influence on Earth began probably 4,000 years ago in some parts of the planet, 2,000 years ago in other parts of the planet. So it is fascinating and very, very scary all at the same time. But we're just much more aware of it, I think, these days, and we're trying to do something about it, which is good news. Anyway, thank you, Christian, for your question, and thank you, Ashley. Lovely to hear your voice, and I'm just so thrilled by your enthusiasm. We're going to take a little break right now, and when we come back, we'll have more questions on the Space Nuts podcast. Andrew Dunkley here with Fred Watson.
Roger, you're allowed to clear here also.
Space Nuts.
Thanks for joining us on the Space Nuts podcast. And I just wanted to let you know very quickly, we have some new propaganda, new items in our Space Nuts shop. In fact, Hugh messaged me the other day and said, we've got a bomber jacket now. A bomber jacket. So go and check it out, spacenutspodcast.com, click on the shop link and see what takes your fancy. It's a brand new book there, by the way. It's really, really now available in paperback. The paperback release date was the 31st of May for the Hitler Paradox. Already got a review on Amazon, Fred. So somebody's a fast reader. Yeah.
Very good.
I got 4 stars. 4 stars.
Hey, that's all right. That's pretty.
No comments,
good.
just 4 stars. Yeah. I'm not unhappy with that. If you start off with 1 star, it takes a lot of work to get yourself back up there again. So a 4-star start is nice. So thank you for that. Don't know who it was. Now to our next question, and this one comes from Marius, who we believe is from Norway.
Hello there, lads. My name is Marius, and I live in the southern part of Norway. Now, I've been listening to you lads for the past 6 months or so. I've gotten through that much of the content to and everything, but so far it's really, really good and really enjoyable. Listen to it at work. I and many others have questions and requests for you to talk about and answer. At the moment, I've currently only built up 10 questions, but more will come. I will only ask a couple of questions at a time that are related to each other as best as I can, but here we go. Now, I use a program software called Space Engine. Have either of you used it or heard about it? If so, could you tell us a little bit about it, share it with the community so they can enjoy it, if possible? And while I was playing around on the game, I found a specific polyline called 1407b. Gotta love this thing. And its ring system is humongous. Could you tell us a little bit about its planets and compare it to something like Saturn or anything else, the solar system even? Thanks for the show, guys. Really enjoy it.
Thank you, Marius. Great to hear your voice. And I I think we can start with the. Did he say it was a game or something? I didn't quite catch it. I thought he said Space Edge, but I'm not sure.
Yeah, it's not something I'm aware of, it's not something I've ever played with, so I can't comment on it. But I can comment on J1407b. So
good segue.
Straight to that, yeah, because clearly they've built this extraordinary planet into the game, which is fabulous. But it is a real object. It is a planet, an exoplanet that is orbiting a sun-like star about 430 light years away. It's a star that's sort of part of a bigger group of fairly young stars like the Sun. So J1407b, 1407b we probably call it. It's a planet that was discovered by dimming the fact that it dimmed the light of its parent star as it passed in front of it, the so-called transit method. And it's a great way of finding exoplanets. But it's as long ago as 2007. The astronomers who were observing this showed not just a single kind of dip in the brightness of the parent star as the planet went in front of it, but this whole complex series of dips, short-term changes in the star's brightness that seem to be caused by differing amounts of obscuration passing in front of it. And what you end up with is the conclusion that the planet is not just a planet, that it's got a ring system as well, and a significant ring system that is also absolutely enormous. So this is the big surprise from J1407b, that its ring system has a diameter of about 120 million kilometers, which means that if it was where the Sun is, it would reach 80% of the way to the Earth.
Yeah.
Forget Saturn. This thing has the most enormous ring system, essentially a solar system-sized ring system. It's only as far as the third rocky planet in the solar system, or 80% of that way, but it's still enormous. And it was in the news again around about a year or so ago, a bit more than a year ago, because there's a gap in the rings. There's a large gap. Which some researchers wondered whether it was caused by a moon orbiting outside the ring system. New research apparently showed that wasn't possible. But what is possible is that there is a baby moon that's embedded in the rings. And we see that in Saturn. Some of Saturn's moons actually orbit within the ring system. So what has to happen now, I can't remember what the period of rotation of J1407b is around its parent star, but there's quite a long wait, I think, before it passes in front of its parent star again. But you can bet when that happens that a lot of big telescopes will be watching it to watch the series of dips that you get to determine what the structure of its ring system is. So it's something that will appear in the news again, hopefully before too long.
Yeah, fascinating. All right. Marius, thank you so much. Sorry we couldn't tell you anything about the game you were referring to, or whatever it was, but I'll be fascinated to find out more about it myself. Let's move on to our next question from John in Barnsley, a text question. Hi, Andrew and Fred. Thanks for the great podcast. I only discovered a month back, but I've been listening to an episode every night since. Get a life, John. No, kidding. Since you said you're running out of questions, I have a couple for you I've struggled to find answers to. Would measurements of the CMB look identical to any observer in any position in the universe? Or would it look different based on the observer's position and their own observable universe? Would the universe have been infinite in size immediately after inflation started? And would the curvature of space-time have been flat during inflation as we measure it to be now? Thanks again, John from Barnsley. It's got a lot going on there. CMB, I'm going to be the one that asks a dumb question. What's that stand for?
Cosmic microwave background.
I knew it. I couldn't think. I just couldn't get it together in my head.
You were there.
COVID-19 vaccination shot for that.
Yeah. So it's a really good question. And John's absolutely right that, if you imagine the universe as this huge volume of space, the bit that we can see is like, I always think of it, I sometimes think of it in terms of, a huge concert hall or something like that. And you imagine a beach ball in it, with us at the center of the beach ball, and we can only see as far as the radius of the beach ball because the cosmic microwave background gets in the way. It's the flash of the Big Bang, which is what we're seeing. And so, observers in different bits of that huge concert hall sized universe will see different beach balls. They'll see a different cosmic microwave background. And I think the patterns on the we detect this tiny ripple of structure in it, and by tiny I mean in terms of its extent. It's the cosmic microwave background is uniform to better than 1 part in 100,000. So we find tiny fluctuations in it, which correspond to fluctuations in temperature at the time that we're looking back to, about 380,000 years after the Big Bang, and those fluctuations will look different in different parts of the universe. But the story they're telling in terms of, how much fluctuation there is and what we call the power spectrum, which is just a characteristic of the pattern that you're seeing, they should be the same everywhere. So the details might be different, but the basic message would be the same. Would the universe have been infinite in size immediately after inflation started? That's the second of John's questions. We don't know that the universe is infinite, but we do know it's very, very big indeed, and it may be. And we think it's the inflation that sort of grew it so big. So I don't know the answer to that question. The inflation lasted a very brief length of time. It was about 10 to the minus 33, I think, of a second, something of that sort. And the universe was different at the beginning from what it was at the end. I don't know about whether it was infinite or not in that time. And the curvature of space-time that John refers to, which we say is flat, that doesn't mean the universe is flat like a pancake. It means that the normal geometry that we understand of parallel lines not meeting and things of that sort carries on throughout the universe. Would that curvature have been flat during inflation as we measure it to be now? Probably not, because we think that one of the reasons why it's flat is because of inflation. So that sort of ironed out lots of things. So that may have also imprinted the geometry of the universe on it too. So some great questions there, John, most of which don't have proper answers, but thank you very much for asking them nevertheless.
Indeed. Thank you, John. I appreciate it. And if you get the impression we're rushing a bit today, yes, we are. We've had some major technical issues. Fred's got a meeting, so we've got to barrel through this one. So it'll be a shorter segment than usual, a shorter program this week. So just apologies for that. I know people like to sit back and relax for the 4 or 5 hours we normally take, but that won't be happening this time. But I'm sure you'll understand that the internet being the internet, it can throw us a few curveballs, which it's certainly done today. But having said that, you are listening to the Space Nuts podcast with Andrew Dunkley and Fred Watson.
0G, and I feel fine.
Space Nuts.
Special thank you to our patrons, the people who put a couple of bucks in here and there to keep us afloat every week. We certainly do want to encourage people to become patrons, but we do not demand it. But if you would like to find out about how you can support Space Nuts financially, go to our website, spacenutspodcast.com, hit the supporter button and see what options are available. Of course, the shop is another way you can support us. We make about a 1% profit on everything we sell there, and that includes my books. But Fred gets 2% on his. He's special. Now, Fred, let's move on to our final audio question for today. And this one comes from Jerry in San Diego, I believe.
Hello, Professor Fred Watson and Andrew Dunkley. My name is Jerry, and I've been listening to your superb podcast and recommending it to every space enthusiast I've come across since episode 1. Today, I am transmitting from San Diego, California. but I am originally born and raised from the Great Plains of South Dakota in the U.S. I have two questions. The first is about NASA's Gateway project, trying to establish a permanent presence on our closest satellite, the moon. From my understanding, they're either trying to build a space station or a surface station. Additionally, I remember in the early 2000s reading a couple articles about NASA contemplating decommissioning or selling their portion of the International Space Station due to a number of reasons. Obviously, that didn't happen. But I feel with the continuation of space exploration, the ISS is going to become less and less relevant. So my question is, why don't the nations that control the International Space Station park the ISS either in one of the Lagrange points as a rendezvous point to the moon, or park the ISS in orbit around the moon? I know this would take a very significant amount of fuel and work to make happen, but I feel like transporting the fuel to space and simply moving a space station would be an easier endeavor than getting the metals to space, then to construct a brand new space station around the moon. For my second question, I was wondering why we don't hear a lot about the Great Attractor, which seems to be pulling everything in our universe to it. It just seems like a very interesting subject, but yet it never seems to get talked about. If you have any information on it, it'd be greatly appreciated. Or is it never talked about because the Great Attractor is so far out into space and so unknown, it's not even a worthy subject to debate? Lastly, I have an idea for your Space Nuts shot. You should take the logo and create Velcro patches or stickers. I think it would be a great seller for anyone who would like to buy stickers and represent the podcast show in their own little way at work or at home. With that being said, I just wanted to thank you for bringing all the corners of this planet together with your fantastic podcast. I feel multinational space exploration and cooperation is one of the few things that really lets the best humanity shine, even amongst political strife. And it reminds us to simply be decent human beings. Keep on cracking out our nutty questions. Thank you.
Thank you, Jerry. I totally agree with him on that political front, and it's something I've voiced several times in more recent episodes. But I'm on the same page with you there, Jerry. I'm pleased to tell you we do have stickers in the Space Nut shop, but the Velcro patches, or just some, maybe patches you can sew on, I will put that to Hugh and see if we can get that added into the mix. That's a good idea. Now, he's asking about, a moon station or a space station around the moon, or moving the ISS as a staging point for going to the moon. Are any of those things possibilities or probabilities?
It's a great idea, Andrew. And the Gateway project it's a mini space station to be placed in orbit around the moon, and that is sort of ongoing. I think it's designed for astronauts before they touch down on the lunar surface. Of course, that is built with 2020's technology, whereas the International Space Station dates from 2000, when it first became habitable or inhabited constantly. It's an interesting idea to recycle it by shoving it out into lunar orbit. And yes, it would need something very, very powerful to do that, but that's not an impossibility, I think. I think in the end, though, it's going to be that the space station, its destiny is for it to be privatized. That's essentially what's been said already by the US government. They're looking at perhaps even as early as 2025. There are 5 space agencies which are involved with the International Space Station. They've got to do some deals on this, but I think there's a good chance that it will end up as a legacy holiday resort for space tourists down the track, but we're a bit of a way from that yet. And I think it's more likely that it will be new hardware, excuse me, that will be used for lunar orbit operations and things of that sort. So, bearing in mind we've got about 2 minutes left, Andrew.
Yes, I know.
Let me go to the second part, which is about the Great Attractor. And since this question came in, I think we've talked about it, Andrew. We did certainly did a segment on the Great Attractor not very long ago. It's the fact that somewhere behind the Milky Way. It's a long way off, but it happens to lie in the plane of the Milky Way, so we can't exactly see what's going on there because we can only see the nearest few thousand light years, not the nearest few 100 million light years. But there is a mass concentration, and it's not something that's not talked about. There's a lot of research going on it. It is probably part of a much bigger concentration as well. It's revealed by the way this great attractor is pulling galaxies towards it. That is still an ongoing, really an ongoing piece of research. We might cover it again in a bit more detail later on. I think the third bit was the Velcro patches. Is that right? I can't.
Yes, that's right. I'll leave that one up to Hugh.
Yeah,
but I think, Mark, Jerry, we have talked about the great attractor before, and we discovered it was a John Deere or possibly a Massey Ferguson. I had to use that joke again because it was so darn good. So darn good. Now, we did have one more question. Do you want to maybe skip it for next week?
I think we might put it on next week's show.
Yeah. Apologies to Mark apologies to Mark in Newbury. We just have run out of time due to other commitments. So we will catch up with you next week. Thanks to everyone who contributed to our questions only episode 255 of Space Nuts. Really appreciate it. To everybody, Ashley, Christian, Marius, John and Jerry. Keep those questions coming in via our website, spacenutspodcast.com, and you can upload them through the AMA app, whether it's audio or text. We don't mind. Keep them coming. Fred, we'll draw a line there. It's not an infinite line either. It's just a basic line across the bottom of the page until next week. I did learn one thing that's going to be beneficial for my future in this episode, that when Judy and I retire, I'm going to be king of the heap because I know how to make her lose weight. We're going to move to the equator. So I'm going to solve one of the great riddles of humanity. How do we lose weight?
Yep.
We move to the equator. There it is. Thank you, Fred. And it's always great fun. Quick and easy this week. Not so easy, actually. But we will catch you next time. See you soon. Thanks, Fred.
See you soon. Thanks, Andrew.
That's Fred Watson, Astronomer-at-Large, part of the team here at the Space Nuts podcast. Thanks also to Hugh in the studio, who's really going to be earning his $1.50 this week. And from me, Andrew Dunkley, thanks for joining us. We'll catch you on the next episode. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.